Okay, so let's talk about something called polyatomic ions. So a polyatomic ion is exactly what the name says. Poly means more than one, atom, and it's an ion. So it's an ion that's made up of more than one atom. So there are many polyatomic ions. There is a list, a chart in your textbook, table 4.3. It's also on slide number 59 of our lecture. There are going to be 7 polyatomic ions that you are essentially responsible for having memorized and being comfortable with, that you will use throughout the Gen Chem series in this course and also 162 and 163. And I'm going to write out those. I'm going to write out their name and the formula. And again, there is a more complete list in your textbook in table 4.3, and also it is in my lecture on slide number 59. So these are the 7 that I will use the most commonly. These are the 7 that you are responsible for having memorized. The other ones, if I asked you about any other than these 7, I would provide the name and formula for you. Okay, so the first one is called the carbonate ion. And the carbonate ion has the formula of CO3 2 minus. So it's 1 carbon, 3 oxygens, and that all together has a charge of -2. So this is an ion. It's essentially an anion because it's negatively charged. Even though it's made up of 2 nonmetals, the bond between the carbon and the oxygen is covalent, but this whole thing is an ion which can form an ionic bond with a cation. So that's kind of confusing, and we're going to work through a few of those. So here's the carbonate ion. The next is called the ammonium ion. The ammonium ion is NH4 plus 1. The next one is called the hydroxide ion. Hydroxide is OH minus. The next one is nitrate. The nitrate ion. Nitrate is NO3 minus 1. The next one is the phosphate ion. Phosphate is PO4 3 minus. And then sulfate. Sulfate is SO4 2 minus. And then the last one is called nitrite. Not to be confused with nitrate. Nitrite is NO2 minus. So these are the polyatomic ions that we are most frequently going to use and that you are responsible for knowing. Okay, so let's look at some examples where I am going to give you either the name or the formula, and then you will do the opposite. So let's write name, formula. So I'm going to write the name of the ionic compound. You'll tell me the formula, or I'll write the formula and you write the name. Okay, so first we'll do calcium carbonate. Then maybe let's look at the formula here. And then let's look at ammonium sulfate. Then we'll write the formula. And now let's write this KOH. And then maybe one more calcium hydroxide. Okay, so for each of these, okay, so you're given one and you're going to do the other. So calcium carbonate. All right. So calcium we know is +2 based on where it is on the periodic table. So here's calcium right here. It's going to want to lose 2 electrons to be like its nearest noble gas. So calcium is Ca2+. Carbonate, there's no way for you to look on the periodic table and see what the charge of carbonate is. You just have to know it. Carbonate also has a charge of 2-. Carbonate is CO3 2-. So now these will give me a neutral charge, +2 and -2. So now I just write it CaCO3, that is calcium carbonate. CaCO3, +2, -2, neutral. So now let's look at this one, LiNO3. Well, I know Li is lithium. I know that from the periodic table. So if I see where lithium is on the periodic table, here it is, it's number 3. It's going to want to lose 1 electron to be like its nearest noble gas, so it's going to be +1. So it's going to be Li +1. Nitrate, I know from my list over here, NO3 -1. So I have +1, -1. It is already, well, we don't have to worry about it because we're looking at the formula. So that's why it's LiNO3. So it's going to be lithium nitrate. So from the formula, you can write the name. Okay, so now these are both polyatomic ions. Here's ammonium, NH4+, and here is sulfate, SO4 2-. So remember, ionic compounds always have to be neutral. So that means because this has a charge of -2 and this has a charge of +1, I'm going to need twice as many ammoniums as sulfates. Remember that we balance ionic compounds with subscripts, but I have an N, an H, and a 4, and I want 2 of all of that. So the way that we show that is we write NH4 and then parentheses 2, sulfate, SO4 2-. Whoops, sorry, not 2-, just SO4. Yeah, NH4 2, SO4. We don't write the charge in the balanced compound. So I have 2 NH4s, which have a charge of +1, so that makes +2. And then I have 1 SO4 sulfate, which has a charge of -2. So overall, this is neutral. So now let's look here. KOH. So K is here, potassium. This is one of the weird ones where the first letter of the atomic symbol is not the same as the spelling of the word. Potassium is K, phosphorus is P. This is one that commonly gets mixed up. Remember that potassium is K, phosphorus is P. So K is potassium. It's number 19. It wants to be like its nearest noble gas, argon, which is 18, which means potassium is going to be +1. And it's with hydroxide, OH. So OH is hydroxide, and that has a charge of -1. So +1, -1, so this is called potassium hydroxide. Now let's look at the last one, calcium hydroxide. Calcium is here. It has a charge of +2 because it's got to lose 2 electrons to be like its nearest noble gas. So I'm going to say Ca2+. And then hydroxide, which is one of the lists that I have to know, has a charge of -1, OH-. So I have calcium, which is +2, hydroxide, which is -1. So I need twice as many hydroxides as calcium, but I need OH, both of those, to be 2. So it's Ca2+, OH2. You have to put a parentheses around the polyatomic ion so that it's understood that you have two of those hydroxides. If you wrote CaOH2, this would be wrong because this would mean you only had two hydrogens. You need these parentheses to say you have two hydroxides, which is the OH minus. So this is some good practice for naming, writing the names and the formulas for polyatomic ions. Again, you are only responsible for these 7. Any of the others that are not on this list of 7, you would be provided information about them. But you will be expected to do stuff like this on the next exam.